Hi, it's Mr. Mac here, and we're going to have a look at the electromagnetic spectrum. This is an introduction to the nature of light. So the inquiry question is very simply, what is light? What we're going to be learning to do is describe features of electromagnetic waves that are used to transmit and receive data. Our success criteria is we'll be able to write explanations about the features of light and electromagnetic waves to find data from distant stars. Well, what are electromagnetic waves? You can see this animated GIF on the top right, and the vertical red sine waves represent transverse wave of the electric field as it oscillates. The horizontal blue sine wave represents oscillating magnetic field, and you can see that both are perpendicular to each other, and both of them are perpendicular to the direction of motion. Electromagnetic waves are transverse waves made up of oscillating electric and magnetic fields. They are invisible and visible waves. They can be seen in, we receive radio waves, microwaves, infrared waves, visible light, ultraviolet rays, X-rays, or gamma rays, depending on their frequency. And the higher the frequency, the higher their energy. Here are some properties of electromagnetic waves that you need to remember. Firstly, they do not require a medium to propagate, since they are oscillations of electric and magnetic fields, so they can travel through a vacuum, such as through space. They all travel at the same speed through free space, regardless of their wavelength, which is known as the speed of light, and is given the pronumeral c. And they are transverse waves, so the oscillations are perpendicular to the direction of propagation. Well, how fast is light? This animated GIF in the top right-hand corner shows a beam of light filmed at 1 trillion frames per second going through a plastic bottle. Pretty amazing, isn't it? The speed of light has an exact value defined as 299,792,458 meters per second. Visible light is the narrower part of the electromagnetic spectrum, and in a vacuum, all electromagnetic radiation travels at the speed of light. Now, that above number that I just read out is accepted as a standard value, and the value of the meter is now defined to be consistent with that number. In a material medium, the effective speed of light is slower and is usually stated in terms of the index of refraction of the medium. Light propagation is affected by the phenomena of refraction, reflection, diffraction, and interference. Now here is a diagram representing the electromagnetic spectrum. This is a very important diagram to remember, and it shows the breakup in the middle of the various parts of the electromagnetic spectrum. So here we have on the left radio waves and microwaves and infrared, and visible is this tiny section right in the middle, and then there's ultraviolet and soft X-rays and hard X-rays, and finally the most energetic gamma rays. These are sort of rays that are produced from stars and from nuclear reactions. But you'll notice it's a spectrum, so there's not nice neat categories of 7 or 8 different types of electromagnetic waves. It's a spectrum that goes from low frequency to high frequency, from low energy to high energy, and at the same time from high wavelength to low or short wavelength. So gamma rays have a very short wavelength and a very high frequency. Radio waves, on the other hand, have a very long wavelength but a very low frequency and therefore low energy. Ionizing radiation comes from ultraviolet and X-rays and gamma rays. In other words, they're so energetic they can take away the electrons from atoms. Please learn this. Have a look at the differences in going from left to right in the frequency and the energy, and also the wavelength. And we'll keep referring to this diagram again and again throughout the rest of the course. Well, I referred to visible light. What can you see? Bees spend their lives trying to find flowers so they can drink the nectar they contain. Flowers often reflect a lot of ultraviolet light, which is invisible to human eyes, but it makes it very easy for bees to see. And many hawks also see ultraviolet light. Hawks don't rely on the ability to see ultraviolet light to find flowers. Instead, they use it to find small rodents and other prey. Well, it's time for a practical investigation, and the first one that we'll do is measuring the speed of light. It's very fast, and we're not going to take a film at trillion frames per second, but we are going to use the microwave oven that's in the kitchen. And this procedure is included on the website. So please have a look at the video that I've made showing how to measure the speed of light using simply a microwave oven, a ruler, some butter, and a calculator. I'm Mr. Mac. Thanks for listening.